Your class, we left off yesterday in 2.1, getting ready to do example 3, part C, right?
Yes.
And I asked you guys to start it, and you guys are saying, what? Because there are variables instead of numbers. Okay? Now, keep in mind, okay, so if we're on the interval from A to C, A and C are what yesterday we were calling our A and B values, right? It's just A and C. Kind of confusing, but we're going to have to work with it. First thing we were doing is we evaluate the function at those two x values, right? So we need to find f of A and f of C. Well, when you put A into that equation, what is f of A going to be?
16a to the third.
Okay, 16a to the third. And we put in C, it's going to be 16c to the third, right? Okay. Now, still going to set up the same idea. Yesterday we were setting up f of B minus f of A over B minus A. This time it's going to be f of C minus f of A over C minus A. There you go, Lynn. Thank you. Okay, so f of C minus f of A means I'm going to say, whoops, 16C cubed minus 16A cubed over B minus A. Well, here it's officially going to be C minus A, right?
Yeah.
Okay, now, the deal is, if this would be in simplified form, we'd be done. We're not quite in simplified form here, though. There's actually quite a bit of simplifying that can be done. You just don't realize it. So what do you notice on top?
Oh, there's a C in there as well.
16.
How about there's a GCF of 16 before we get to C and A? Okay? So I'll actually take it so I remember to grade it later. So if we factor out that GCF of 16 on top, I'm going to have 16 times C cubed minus A cubed over C minus A. And then we're not done yet.
What else can we do?
What else can we do? Okay. It's all out of sorts here.
Oh, man.
Now, first of all, let's get past the obvious. I'm guessing what Connor's saying, based on what Connor said earlier, he just wants to cancel the C's, cancel the A's,
Well, I mean, you can't completely cancel it.
Okay.
You can cancel them a little bit.
Well, okay, but we can't just say, oh, there's a C, there's an A, I'm going to cancel a C and an A, because this is a subtraction. This is a C minus A. So we have to cancel factors here. Which, okay, C cubed minus A cubed is something called difference of cubes, and it factors. I taught it last year in Algebra 2. I taught you guys how to factor. No way you remember it, okay? But it factors.
I remember discussing it. I don't remember it at all.
Okay, so GCF of 16 out front is going to stay 16. When you factor the sum or difference of perfect cubes, it factors into a binomial times a trinomial. And I taught a formula type thing for it last year. The first piece we're going to do is the binomial. And in order to do this, we just take the cube root of each of these terms, and we keep the sign the same. So the cube root of C cubed is C.
So it's just C minus.
Keep the same sign, so we keep the minus. And the cube root of A cubed is A. Okay, that's your binomial. And if this had been C cubed plus A cubed, this would just be C plus A here, right? The trinomial. Okay, the first term of the trinomial is your first cube root squared. So if my first cube root was C, and when we square it, that's going to be C squared. This next term is the opposite sign of what the original problem was and what the first parenthesis was. So this sign is going to be plus in this case. My middle term is my two cube roots multiplied together. So we had a cube root of C, a cube root of A. C times A is CA, or I'm actually going to say AC. My final term in my trinomial is always plus, and it is the square of the second cube root. So my second cube root was A, and A squared is A squared. Okay? We factored something like that last year. We didn't do a whole lot of it, so I know it's not fresh in memories. Okay? My denominator was still a C minus A. Now, was that factoring beneficial? Yeah, because what can cancel now?
C minus A.
A factor of C minus A is on top, and we'll cancel with the factor of C minus A in the denominator, leaving me with a final answer of 16 times the quantity C squared plus AC plus A squared. Okay? That factoring of the sum or difference of perfect cubes does pop up every so often. Okay, so that's something we have to work to know how to do. And I'll always walk you through it. But I'm always going to walk you through it the same way I just walked you through on that one. Okay? Okay, so there's your complicated average rate of change example. Okay? Okay. Now, I will say, it just occurred to me, off the top of my head, I want to say 78 is your average rate of change example when you go to do homework. But 78 is one of those, like, 78 is like 10 problems itself.
Oh.
That type. So you're doing, like, A is an average rate of change. Like here we just did 3 of them, right? I don't remember how many 78 is, but it is quite a few parts. Each is its own problem. Okay? If I recall, you do see this sum or difference of cubes. Okay? And again, I haven't looked recently, but that's what I'm recalling. Okay. My point is, don't get to 78 and just skip the whole problem because I won't give you credit for completing the homework if you just, oh, I forgot to do 78. Well, you just skipped like 10 problems then. Okay? So, okay. The other thing I want to talk about today is linear correlation. So, with linear correlation, first of all, as you guys look at these examples, we don't usually necessarily refer to them as linear correlation. Probably you learn them as scatter plots.
Yeah.
That's what I think of them as.
There's so much.
Okay. Now, scatter plots are linear. It's linear correlation. Okay. It's the idea of how do those points relate to each other? Do they have a linear correlation? So when we graph tables of data using StatPlot, do you remember how we used StatPlot to graph earlier this year? We're going to do it again today. We can tell whether or not the dots are clustered along a line. If they are clustered along a line, we say there is a linear correlation. And that linear correlation could be a positive correlation or a negative correlation, depending on if they're going the direction of a positive slope or if they're going the direction of a negative slope. Okay? It is also possible for the graphs to have little or no linear correlation. And this specific example talks about you can have a strong correlation or a weak correlation, just how well are those points clustered around the line. Okay, so a couple examples here just to, these first 2 examples, you see the positive correlation, yes? This first one especially because the points are clustered around what looks like an increasing line, yes? Because it's that increasing line, it's a positive correlation. First example is a strong example because it's very definite, right? Very tight around that line. Second one, you can see the correlation. It's a little weaker because they're not as tightly clustered around the line. This middle example, when you've done scatter plots in the past, you would have just said no correlation, okay? Because the dots are just everywhere. They're not clustered around the line. And then these last 2 examples are examples of negative correlation. This first one right here, you see the dots formed around a line that is decreasing, right? very tightly clustered. Whereas this one, same thing, but loosely clustered around that line. Okay, so positive, negative, or no correlation. Okay, so example 4. We are given a table of weekly sales data based on market research for prices of boxes of a certain breakfast cereal and the number of boxes sold. First thing it's asking is to describe the strength and direction of the linear correlation. Then it asks us to write a linear model for the demand as a function of the price of the box. Then it asks us to use the model to predict weekly cereal sales if the prices drop to $2 or raise to $4 per box. Okay. We got some stuff to do here, don't we? So, the first thing it's asking us to do is describe the strength and direction of the linear correlation. This is positive correlation, negative correlation, no correlation. So what do we need to do to figure that out? We need to graph them. Now, we can graph them by hand. No is right. Or we can graph them by stat plot, which, this is why I said have your calculators out, because do we remember how to do this?
Kind of.
Exactly, kind of, but, you know. Okay.
Oh, shoot.
Okay, my calculator did not charge at all earlier.
Gosh.
Okay, so, I don't know why I'm on this screen. First of all, remember, on the TI-84s, you go into Stat. You hit the Stat button, which is next to your keypad, your arrow pad. And then, you can't turn around and ask a question yet. I haven't even gotten
I
anywhere.
figure out how to get out of y equals.
Do a second quick.
Where's the, oh.
How do you ever get out of y equals?
I just turn it all the way off.
Oh my God, then turn it off. Okay,
I want to
so, I went into Stat. And then I'm going to go ahead and go into number 1, Edit. Now, who knows what I last did, but I have numbers in my columns that I don't want there. You can go up into the column heading, and you can clear the numbers in the column. Clear, enter. Do not delete, or you will delete the entire column from existence. Okay? So if I go up and I want to get rid of L3, I'm going to do clear, enter. If I want to delete these values, I'm going to go into L2, clear, enter. If I go into L1, clear, enter. You delete, that column's just gone. And I don't know, there's a way to get it back, but I don't remember how. So, in my L1, what numbers am I going to put in my L1?
The price.
The price. What's going to go in L2?
Boxes sold.
Boxes sold. Okay? Let's get typing. Okay. I did not type zeros in because, hello, zeros unnecessary there, but 2.4, 2.6, 2.8, 3, 3.2, 3.4, 3.6. Do the zeros even stay if you type them in?
No.
Okay.
I tried.
Be smart, guys. Is there a difference between 3.6 and 3.60?
You saved me for a second here now.
Okay. Okay. Well, I at least know I have the correct number of numbers because my columns are equal in length, right? Doesn't hurt to double check, make sure it looks like you've got correct values punched in. Okay, now, to graph these, let's see, where do I want to go? First of all, we need to go turn a stat plot on.
I did that.
In order to turn a stat plot on, I can go into second and y equals because stat plot is right above y, correct? So second, y equals. You need to turn one of these stat plots on. And I can enter into here. I want it to be L1, L2. I can just hit enter on the on. The other way you could type, do you remember also you could go in here and do y, just the y equals, and you can just go and turn the plots on up here. I always forget this. So that's easier, is to just turn it on and off up there. Now, if I have no idea what I last graphed on this back there. So if I hit zoom 6 and I go into graph, let's see, do I have any dots on my screen?
No.
I
didn't
don't.
show up.
Why do I not have any dots on my screen?
Oh, the windows too.
Okay, my x values range from 2.4 to 3.6. That's not the issue. My y values range from 18 to 60 to 38 through 20. So I'm going to go in and change this by hand because zooming is not, it's not going to be very, helpful. So I'm going to go into window. So my X-min and X-max, I'm not going to go just 2.4 to 3.6, maybe 0 to 5, 0 to 10, right? Something like that makes sense. So my X-min 0, I don't remember. Let's just try 0 to 5. If you want 10, keep 10.
0 to 5 makes it look better.
Okay. Y-min. I don't need a Y-min of negative 10. Do I even need a Y-min of 0? No. 18 to 60, so I'm going to go 18,000. I could even go 18 to 50, I could get really close there. Y max, something bigger than 38,320.
40,000.
I just 40.
Oh man.
You did 40,000?
Yeah.
I'm
That's
going to
what
do 39,000. I don't know. It's not going to make much of a difference.
Interesting.
Okay. Your graph looks something like my graph, depending on what you did.
Very similar.
Yeah. Pretty much the same.
Okay. So, our first question was, describe the strength and direction of the linear correlation.
Oh.
Is this positive, negative, or no correlation?
Negative.
There's definitely correlation, right? And if you look carefully, it is a negative. Strong?
I'd say strong because they're pretty straight.
So I would say this is a strong negative correlation. And honestly, I'm pretty flexible on the strong versus weak. The negative is what you have to get there, right? You got negative correlation, that's, that's the key that I'm looking for on that piece. Okay? So that describes the strength and direction of the linear correlation. Now, the next piece of this problem says to write a linear model for the demand as a function of the price of the box. Okay, we can do this two different ways. We can do this the algebra style, where we have to find a slope, we have to find a y-intercept, and do it that way. Or we can let the calculator do the math for us
Me personally.
as what is called a linear regression. Okay, so we're going to write a linear regression. Okay,
Oh my gosh, I learned this.
you have the values already entered in your calculator, right?
Yeah.
Okay, so we're going to use those lists. And I got to practice this morning, so we'll see how well I do with my own notes from last year or previous year. So we're going to go into stat, the same button we started with today. And instead of just hitting enter and edit, we're going to go over to calc. So we're in the stat menu under calc. And as you look there are some linear regression options. There's linear regression option number 4, which is ax plus b, which is the one we're going to use. There's also linear regression number 8, which is a plus bx. But keep in mind, we're looking for basic, like slope-intercept form, mx plus b, and traditionally that is written as ax plus b. So we're going to go into option number 4, linear regression, ax plus b. I'm going to hit enter. Now, where are my x values? Are they in L1?
Yeah.
So I'm good. If not, you need to change, right? Where are my y values?
L2.
They're L2, so that's good, yes? Again, if not, you need to change that. And then from there, we don't have to worry about the other thing. Arrow down to calculate and hit enter.
Perfect.
Okay? So what that is saying, in the form y equals ax plus b, your a value is that negative 15,358 number. So my slope is negative 15,000 whatever. Does it make sense my slope is negative?
Yep.
Yeah, we said there was a negative correlation. And my y-intercept is 73,000 some. Well, this is negative. It's going to be up there somewhere, right? And it's a very steep negative. So those are your a and b values. There is your equation, essentially. So if I write this equation, this is y equals, if I just use the numbers as provided, negative 15,358.92857 times x plus b, which is 73,622.5. Okay. In my notes, I have a cleaned up version, which just goes to 2 decimal places, which is negative 15,358 and 93 hundredths x plus 73,622 and 5 tenths. Okay. There's the second piece we had to do. Write a linear model. Now, before I move on, how did we get to there?
With the calculator.
We went into stat, right? I'm going to write you a few quick notes because otherwise you're going to get home, you're going to be like, where did we go to do that? Right?
Stat.
Okay, so we went into stat,
That's when we call it.
and when we went into stat, we went over to calc, right? And then once we were in calc, we went to number 4, linear regression, ax plus b. And once we were in there, we made sure it was x1 or L1, L2, and then we went down to calculate. Okay, there's your little cheat sheet of what the heck did we do to get that answer.
I think we should get that.
Oh.
Do we get a little note card for this one, or like an inch by inch piece of paper?
We're in lesson 2.1. I haven't.
That's the last time we've had.
I was gonna say probably not.
We should.
Okay,
We should
there we go. Now we're not done yet.
Oh my gosh, no, we're not.
We're not done.
There's more?
There's more.
Oh gosh.
Okay, so right there we wrote a linear model for the demand as a function of the price of the box. Next part. Use the model. What do we mean model?
Graph.
The graph or
The graph.
the equation. Okay, we're going to use that equation to predict weekly cereal sales if the price of box price is dropped to $2 or raised to $4. So use the model. We're going to use the equation. And we're going to have to look at when the price is $2 or when the price is $4. Okay. Short of it, yes. We're going to plug those numbers into the equation. Now, there's 2 different ways you can do this. Okay? And let's see. Okay, so first x value we're going to use is x equals 2, yes? So you can just plug it into the negative 15,358.93 times 2 plus 73,622.5. Okay? Now, you can do that. If you have to do this problem a bunch of times, you can retype that a bunch of times. You can copy and paste. I've shown you how to copy and paste, right? Or if you go up to a previous problem, you can just hit enter, it recopies it, and you can just go in and edit it. I may show that here in a moment.
What I want to know is how you can erase a single number
Yeah.
Without
I can
erasing
show you that.
the
You hit the
entire thing.
delete
Without
button.
erasing the entire
Okay, so now let me show you what you should be getting. I'm going to show you two different ways to do this. Okay. Grab this so I can see what I'm typing here. So, one option, if I just go into my regular screen, I did a second quit to get out of something. That's what I always do.
I appreciate it. I had no
Okay.
idea. I just
That's-
turned it all the way off.
I know. And that's the other option, but I always just do second quit if I'm stuck somewhere and I want to get back to the main screen. Okay? Now, so one option is I can do negative 15,358, whoops, 0.93 times 2, thank you, plus 73,622.5, and I get that answer, yes? Now, I have to redo that same problem, yes? But instead of using 2, I just want to use 4. I can retype that whole problem. I prefer not. Okay? Give me a pass. Okay. Or, on these calculators, I don't know how well you can see the highlighting. I can arrow up. You see how that, what I typed in is highlighted? I hit enter. It recopies it down there. And I can just arrow back. I need that 2 to magically become a 4. And now I have my next answer.
The only
Okay.
issue is whenever you have to recopy it and then the number's bigger.
Okay, so
I did something wrong.
let's do a pretend. I copied it up there. Now, instead of this 4, I want this 4 to become a 14. If I just type a 1 here, it's going to replace the 4. So I can insert a digit, is what I can do here. And so to insert a digit, I have this delete button, which is right here, DEL, right? If above it is INS, insert. If I do second and insert, and then I'm on the 4 and I type a 1, it just inserted, Kylie, right above DEL, is second insert. And so now I have 14. Not that 14 is part of this problem, I'm just showing calculator fix it.
Okay.
Okay? Now, if I want to delete just that, if I delete just 1, I can just use DEL, right?
Yeah.
Yeah. I can just use DEL to delete 1.
Oh.
If I use the delete button, that just deletes 1 character at a time. And if you use insert, which is the second function of delete, you can insert 1 character at a time.
That makes
Clear
sense.
will clear the whole calculator
That
line.
was so much help. Thank you.
Okay. So if you've typed in a whole bunch of junk and you realize a mistake back in the beginning, no, you don't have to clear your calculator entry. Now, okay, I have one other option for you. We never graphed this line, and I meant to have you graph this line, to see, does our line fit our points? Because we can also use that to get our values. So I'm going to go back to y equals. You know that equation we found in part 2 here, so to speak? I'm going to type that equation in. If this isn't a good equation, it should overlap. Those points are already on my graph, yes? So if I type in y equals negative 15,358, whoops, 0.93x plus 73,622.5, and then if I graph that, so I'm just going to hit graph. I'm not going to do a zoom 6 or change anything. And if I graph it, notice my line should go nicely through my points, doesn't it? Okay. If I would have already put this in there and had it in there, if you are trying to find an x value, or what, not find an x value, find the y value for an x value, if I click trace here, see that trace button? If I click trace, now, right now it says I'm on plot L1, L2. I don't want to be on the plot, I want to be on the line. So do I arrow left or right, or up or down? Okay, left and right takes me to other points. If I arrow up or down, now it shows that I'm on Y1, I'm on the line. If I type in a value, so what was our first value, 2?
2.
If I type in 2, it says x equals 2, and I hit enter, notice, what is the value on the equation? The ordered pair is 2, 42904.64. If I hit trace again, and again, it takes me back to plot. I don't want to be in plot, so I'm going to arrow to the next thing that's graphed, which is Y1. But I enter 4. Is that the answer I got earlier on the calculator screen? 12186.78. I never wrote it down earlier, but it's what I have there. Okay, so those are different ways to, if you're given an equation, to not have to retype it every single time. Now, I will say the book does some rounding here. This 42,904.64, well, what is this? This is cereal boxes sold, right? So you're probably not going to talk about 0.64 of a cereal box. And I will say they round to a nice, neat number. The book says like 42,900 boxes on this one. Okay? You know, obviously, as long as you're here, you've got the right idea. Okay. I'll write down my answer here. When x is 4, you should have gotten that y is approximately 12,186.78, which is, according to them, approximately 12,190 boxes. You know, if you said 12,188, or if you said 12,200, you're in the, you know, right idea here. They're giving estimated answers. Now, do I need to put clues? Okay, what are the possible ways? You can substitute the x value into the equation, or we can trace the line and enter the value. So, those are the two different ways I showed you. Can substitute x value into the equation. And if nothing else, that's the kind of go-to there, isn't it? Or you can trace the graph and, all right, well, trace the graph or trace the line, graph, line, whichever. Trace the line, I'm going to say, on graph and enter the value. Okay? Those are your options to help you know how to do that when you look later. Okay? That's my stopping point for today. Okay? The homework that is listed goes with exactly what we've done so far. So the homework that's listed is due tomorrow. And then, so we'll check homework tomorrow, and we'll start into the quadratic page tomorrow. Depending on timing, we won't necessarily get all the way through the quadratic page. That may take into Thursday, depending on the situation. There is a separate homework that goes with the quadratic page. Okay? So, make sure if you haven't already written it down, write down your homework. What page number is it? 163? 2 through 12 evens. 45 to 48. 53, 68, and 78. And again, I already gave you the warning, 78 is like 10, 12 parts, something crazy. I'll be honest, okay? But it's all practicing average rate of change. Okay? You have a little bit of work time.